Hey ladies and gentlemen, it's Steve here with Tweaktown, and today I'm going to show you how to overclock a 9900K on a Z390 Aorus Master motherboard. The same basic principles and like BIOS layout and stuff like that apply to all Gigabyte Z390 motherboards. So this is Gigabyte's new skin for their motherboard, and it does have a few new features, like it'll show you good descriptions for what the settings do. Load line calibration has a graph now. So some things are the same. Smart Fan 5 is the same, Q Flash is the same. So if you want to upgrade your BIOS, like right now we're on F6B, we hit F8 in the UEFI, we select it, the new BIOS that's on our USB stick, and update it. Anyways, we're not going to bother with that. What we're going to do is go to the classic mode by pressing F2. I have no idea. Whoever was the first motherboard vendor to go make an easy mode, I think it was either like Asus or ASRock, please go back in time and change that. I mean, what's the point? Anyways, I'm sorry, I was just rambling. Sorry, I've been in this. This is like my fifth take of this video. Anyway, so you're going to land here when you press F2 once you're in the BIOS by pressing delete, or when you see the number lock sign come on your keyboard, you hit delete, you'll get into, even if you don't see the screen. Anyways, so here's your MIT menu. You have advanced frequency settings. Now this is where we're going to set stuff. But let's say you want to use your mouse and it's not moving fast enough for you. We can hit the keypad over two arrows and we go to BIOS. We go down here and we go to mouse speed, and then we go to by 4 or by 3. By 4 is a bit too fast. By 3 is good. It doesn't change real time, so please don't expect that. You do have boot options here too. This might be the only other menu you might go to. There are peripheral menus. Oh, here, USB DAC up too. This is a Gigabyte feature that's unique. You can increase voltage or totally disable voltage and only do data out of the USB port for audio devices. That's why it's called DAC up. But you can also increase voltage for long distance cables, stuff like that. So you got USB configurations, all the other stuff no one ever touches for like normal consumers. Here we go to MIT menu. This is where you do your overclocking. Advanced frequency settings. Base clock. I don't know why you changed this. I don't know anyone who actually does anymore. Since Intel introduced ratios, no one's touched this. Graphics slice, unsliced. This is not your graphics card. This is the internal graphics of the CPU. You can't overclock your graphics card from any BIOS of a motherboard. CPU upgrade. These are Gigabyte's like basic profiles that engineers devise, but their issue is that they have to support all the CPUs at that frequency. So even the worst ones, which means that they're probably going to be a little bit too high on voltage for you. Enhanced multi-core enhancement. So this will take all your cores up to maximum, the maximum multiplier that only 1 or 2 cores should have gone to, which is 5 gigahertz on the 9900 K instead of 4.7. We're not going to use this because we want to set everything manually, because that's how we get the cleaner overclock, lower voltage. So CPU overclock ratio, 50x here. That'll give us 5 gigahertz. All your ratios are multiplied by your base clock. That's why we don't really change it. But also because the system's just not designed to have it changed at this point in time. Yeah, the capability is there. Gigabyte even adds in a clock generator just to change that. But no one uses it past the extreme overclockers who need to increase memory frequency. The multipliers are higher than needed. Before we go in here, let's talk about F-clock. 1 gigahertz is perfect for graphics. This is the highest you can go. And don't go lower. Extreme memory profile here. There is a memory menu, but we're not going to go there. Well, we're not going to use it, but we will go there. So we're going to enable this. This will take my memory frequency to 3.2 gigahertz. It will take my timings to where they should be. And it should take my voltage, so I don't have to touch anything for memory after that. One and done. Advanced core settings. AVX offset. Let's say I'm running Prime 95. The newer one uses AVX. AVX are units... Sorry, that's not correct. Intel CPUs have AVX units built into them. They're wide, they're hungry, and they get hot. And when things get hot, they consume power. But also, when you're enabling and basically using units that aren't usually used by traditional things like games that use SSC instructions and stuff, you're going to use a lot more power and you're going to push stability. So, let's say my CPU does 5.2 gigahertz perfectly in games, but doesn't do 5.2 gigahertz and stuff like Prime 95. Then we can set this to something like 2. If we set it to 2, then my CPU will go from 5.2 to 5 gigahertz, as long as I set my CPU frequency to 5.2. Okay, so this would result in 5 gigahertz AVX and 5.2 non-AVX, stuff like games. Now we're not going to mess with that because I do actually use AVX stuff, like Handbrake uses AVX, Blender uses AVX, And we use Handbrake to edit this video, to be honest with you, because this is a capture card and it captures way too big files. I mean, the lowest thing it can capture is 8-bit YUV. I mean, come on. TJ Maxx temperature, not gigabyte. Intel added this in. All motherboards have it now, and basically allows you. This is default thermal throttle point 100 100 C. Intel lets you take it to 115. We're gonna set 110 just for the purposes of stability testing Prime 95. Prime 95 will stress your CPU like nothing can, and so you might want to set this at 110 so that you don't like throttle and think you're stable. Uncore ratio by default it's 47 when I overclock. I'm gonna just type it in just to be sure. Don't touch, don't touch, don't touch, because they do nothing on this motherboard or any other really, to be honest with you, in this generation. And that's good because why do you want to change 50 settings? I set 255 here as a force of habit. You probably don't have to. That's a core current limit. That's an Intel maximum. Enhanced C state, disable. C3, disable. C67, disable. C0 is actually your awake state. There's 5 of these you have to disable. By disabling these 5, your CPU will not drop frequency when load is low. Why do I want to do this? Because I'm greedy. I like my megahertz, you know? Why should it run slower when I'm only running single-threaded or whatever? Anyways, I want it to run 100% all the time. Now, there are a lot of people who don't want it to run 100% all the time, but do want the 5 gigahertz when overclocking. For those people, you are basically going to enable these. Leave them enabled, and we'll show you how to get the voltage to drop as well when we go to the voltage page, which is next. You can also disable a bunch of this stuff. We found no difference with it enabled or disabled. Yeah, so anyways, memory, I told you I'd go over it. That's your memory multiplier. This is like a multiplier for the base clock, so you can go like, that's how you get the DRAM like 3466 is through this reference clock, and then there's an odd ratio enabled too. Boot mode, you want fast boot? Great, but a lot of memory requires training. Training is like sending a player down a field and then back, and then timing that against your best player and saying, I don't know. It's just calibrating. And it takes time, but it like a multiple reboot cycles, or you see a postcode cycle a bunch of times. That's what happens if you disable fast boot. Enable fast boot will not do it. Auto will probably enable some training, not a lot. Real-time memory timing, like in Windows, you can mess with that. Enhancement setting, these are like easy to use stuff for beginners to lighten up some subtimings in the background. Timing mode, manual will allow you to change both channels at the same time. Advanced manual will allow you to change them independently. So you can, channel A can be different than channel B. I don't know why you want to do that. Or maybe 2 different kits or something. Advanced voltage, okay? Core voltage, CPV core. What we're going to do is type in 1.275. We know that's good. We know that's good with a turbo level LLC, but I did promise to show you how to make your voltage drop. On this board, you type in N here for normal. You saw that dynamic V core just opened up. Now, let's say okay, so when we go vCore normal, we're letting it basically, we're telling the CPU, listen, you can use SVID to find what you want, but the CPU, just like I like it to run 5 gigahertz all the time, it likes to run at a higher voltage than it really needs. So I might want 1.27 when I'm overclocked at 5 gigahertz, but it might give me 1.32. What's 1.32 to get to 1.27? 0.045, right? Okay. So what we do here is we go to dynamic vid, and we press page down. And we said what? 2.0.045? Yeah, 45. Okay. If my vCore on auto at 5 gigahertz, which you're going to have to find out by actually setting 5 gigahertz, hitting F10, coming back in the BIOS and seeing what it is, and then put your offset in, then this would give me 1.275 at full, and then it would allow the voltage to drop down at idle. You can also just not let the voltage drop. The power differences are not that big between letting voltage drop and not letting voltage drop, because current is one of the big things that happens, and that's not happening when you have low load. But anyways, that's how you do that. So that's how you do it on a Gigabyte board. Hit auto here because that's not going to be used, and I just want to do a normal overclock. Okay, SVID offset, don't touch. Base clock adaptive voltage, this is like if you overclock the base clock, and this is just does it itself. Okay. Grabs voltage, no touch. This is the only other 2 we touch normally. Everything here and below is like cold bug stuff. Like these PLLs, they help a lot with cold bugs. And that's like negative 120C stuff, don't touch it. VCIO. Let's say I want to run like 4 gigahertz memory, and my internal memory controller isn't that great. You know, like 1.25 here, 1.25 here is max. We could do something crazy like go 1.25 here and then go 1.2 here. Try different combinations, make it work. Some CPUs are finicky. No need to actually touch them for most things. So yeah. Chipset voltage, useless for us. DRAM voltage, it's going to be set to 1.35 anyway. Internal VR control, don't touch. Advanced power settings. You have an internal and an external LLC. Now look at this. It shows me my whatever, auto, normal, standard, low, medium, high, turbo, extreme, ultra. 1, 2, 3, 4, 5, 6, 7, 8. Oh, that's... Never mind. I just realized something. Anyways, turbo would be like level 6 in other BIOSes. Internal AC/DC load line. Okay, so this will basically, you see when I change the turbo and move that thing, you see extreme moves and ultra extreme. Ultra extreme will actually make the voltage go up. Extreme will also make the voltage go up. Turbo allows it to stay around what I set. Now let's say you're turbo but your voltage is dropping a little bit more than you like. You can go here and increase this to turbo as well, and that should give you a little boost in between setting turbo here and extreme. So it's like an in-between. AVX load line, I don't know why you touched this. You could increase this. I don't know why, I wouldn't. Current protection, you can increase this too. You can use a page up, page down to just go instead of the arrows. Well, never mind. Yeah, don't hit left and right. Hit page up, page down. You can go extreme here. That will give me less protection. Switch rate. Higher switch rate is higher transient response. But it means higher temperatures too. Lower is lower transient response, but more efficient. Here's the deal, guys. You didn't design this voltage regulator. Who says you should be able to pick what rate it switches at? That's 400,000 times a second those phases are turning on and off. Don't touch this. It's not required on this board. This is here because a few generations ago, another vendor had an issue where they set it to load by default, and so they needed a way to let users increase it to overclock. Gigabyte didn't make that mistake. It's just here, and they want to let you go up and down a little bit. 500 kilohertz would be 1 megahertz effective at the PWM, and then the doubler splits it in half. So we're running 400, so we're running 800. Okay, good. 400 is solid. It's a little bit higher than before, but it's nice. Phase control, extreme perf. This will basically balance whether or not you want the voltage regulator to favor current over temperature. So do you want the voltage regulator to be more aggressive, or do you want it to be more power savings? You want it to be aggressive, especially if you're overclocking. But we don't need to set this, but we will, because you know what? Voltage regulator on this board is solid. Cooler is solid. It's going to destroy whatever CPU is in there in a good way. It handles voltage really well on this motherboard. The voltage regulator is solid, high quality, and pretty expensive, to be honest with you. IR solutions tend to be. Now, on that topic, not all of these settings will be here on every Gigabyte board or any board. You get all these settings because this is an advanced digital pulse width modulator controller. What that means is that this PWM controller is basically very smart, and it's able to balance current, able to detect current at the integrated power stage and relay it back as needed, right? Because each phase is only on at one time, right? Even with a doubler. Anyway, so phase control. We went over that. Okay, nothing to go over here. I don't know. Let's get into a little tangent. Anyways, so here you have all your settings. Yeah. Also, this internal AC/DC load line is the same as going here and changing the ohm on the AC and DC load line. IA means like the actual cores. GT is graphics. Don't touch any of these. Don't disable SVID. Don't do stuff like that. There's no reason. These have already been maximized for you. Anyways. So, if you want to change fans, that's where you do it. Smart Fan 5. You do need a mouse for this, I believe. I think so. Yeah, it's okay. Yeah, you need a mouse for this. You just drag and drop these points. Fan speed control, manual, and these points enter. There's 6 of them, I guess, or I guess 0 is at 0. You can choose your temperature input, so you can go with any of these. There are 2 external temperature probes that come with this motherboard and 2 headers, so those would be there. Like you stick one in your GPU and have a fan blowing at your GPU, and it can increase based on that. So you have control over all your fan headers like that, all of them. And not only that, you also get to pick between control mode. so between PWM and DC or voltage, and fan stop, which allows your fan to stop if temperatures are low. Right now, temperature is pretty low. Okay, so we've set everything, and then we hit F10, but we're looking here, and we can see everything we've changed, right? And we could scroll down this menu. Fan speed control, manual, no need. Extreme perf, we set our voltages, dynamic vid. So it shows auto on everything I touched and didn't actually change. I set our ratios, yeah, and so yes. Okay, now we're going to boot into Windows. This is the fun part. I'm just going to show you quick and easy. I know people don't like to watch really long videos, so yeah. Wow. So, cool little fun fact for you. This little 15 minutes has taken up 150 gigabytes on the PC I'm currently in front of. So I'm actually, okay, so when we get into Windows, there's going to be a little bit of a lag because I'm watching a recording of what's happening there captured into another PC. And, yeah, so there's a little delay for me, but not for you. Okay, let's look at CPU Z. Now, we set high performance power plan in Windows, and that should be good. Give me a second, it's really small. Okay, we're at 5 gigahertz. Check the memory, should be 1600 megahertz times 2 is 32. Yay! Cache is at 4.7 gigahertz. Yay! I like HW Info. It's a smart program. So, okay. I'm going to move this here. I'm going to open Prime 95 because it's my CPU's favorite program. It just destroys it. Small FFTs. This is going to stress your CPU the most. Blend will do tests where like test a bunch of memory, cache, stuff like that. Blend will just nail the CPU core. It just focuses on the CPU. It's very good at it. So here we have well, not handbrake. We have all the CPU ratios, temperatures. This is like reported, but since there's no internal voltage regulator, it's not the most accurate. And then here are your warning flags. So if you set any of these off, something's wrong. Except temperature. You're going to exceed max temperature here if you use the offset, but if as long as thermal throttle tags don't go off, then don't worry, flags. Temperature 5 on GIGABYTE motherboards is the voltage regulator temperature. Now it's not the internal temperature of the MOSFETs, but an external temperature sensor the SIO reads and then reports. The internal one, the PWM only knows. So yeah. Okay, so now we've gone over that. Oh, I want to show you something else. There's a Blender benchmark now, and the Blender benchmark is actually, it uses AVX. Now, it just is like a real-world situation for your CPU, so, yeah. Anyway, so here we go. Let's see how hot we go. Anyone want to take bets? So we're starting all workers. And you might hear the fans roaring behind me. You see the voltage here is not the voltage here. This is vid. This is like what I was talking about, the offset if you want CPU frequency to drop. This is what actually going in the CPU. CPU-Z is pretty accurate with GIGABYTE on Z390, so that's good. But you see, CPUs are quickly going into the hundreds. So that's basically how you do it. Your CPU is going to run like this for hours. It's going to get really hot, and it's not really fun. But you see here, 6 degrees before offset. So it must have gone up to 104, right? Yeah. So basically, it is offset. It is seeing my TJ Max. I have set off a flag here. Oh, not yet. Well, I'll probably set off a flag here on maximum CPU temperature if it's still there. But there's been no thermal events and no throttling. So basically, ladies and gentlemen, that's how you do it. Hopefully you get a CPU that leads less VCore, or maybe this is a bit too much VCore. I gotta go just lower it a little bit. Maybe I changed the BIOS version since last time. Anyways, ladies and gentlemen, thank you for watching. So once you run this for an hour, you can go back, lower VCore, and then run this again. And then finally, when you're someplace where you're good with temperature, you can just let it run for like... Oh, I'm using a different cooler. I usually use a H150, but this rig system over here only has a H110. That's why I'm going. I should only be hitting like 95. Okay, so that's why, ladies and gentlemen. Oh, never mind. That's why. Okay, so you go down you run this for an hour, then reduce the vCore another couple millivolts, like 5 or 10 millivolts, and then run it again. If you pass, good. Keep going lower until you don't pass, then go back up, and then run this for many more hours. Some people say you got to run like 48 hours of Prime 95. I don't know if I'd run my CPU 48 hours. Some people just want it 100% stable, and that's the only way you can do it, really. Or you could use offset. Anyways, thank you for watching, and I hope you enjoyed this movie.